All right, we're going to continue with modeling with exponential and logarithmic functions. I'm going to start with example 4, finding an exponential model. Use technology to find an exponential model for the data in example 3. Then use this model and the models in example 3 to estimate the number of visitors in 2020. Compare the estimates. All right, so I brought the table over from example 3. This is the same table we used in example 3. And I'm going to show you how to do this using technology, meaning using your calculator. All right, so the first thing I want to do, so I already cleared out my calculator. So second plus 712, that clears everything out of your calculator. Once you do that, you want to go to second 0, that's your catalog, and scroll down to it says diagnostics on. All right, so I'm quickly going to show you that. So catalog, probably can skip down to D's, but you're going to go down to where it says diagnostic on. So you don't have to have this turned on for this example, but sometimes on the EOC and sometimes on standardized test, it says which model is best. If you need to know which model is best, you need to be able to see your correlation. You need to be able to see whether the correlation is a good fit or not. So here's diagnostic on. So click it twice so it says done. And that means now when we write an equation, it's also going to show you that R or R squared, which tells you how good a model you have. So if you are comparing, if you just had a table and it says what type of function best models this type of data, and you're looking at linear, quadratic, and exponential, it's good to have the diagnostic on because you can compare those numbers and it'll tell you which function is the best one. But back to example 4, finding an exponential model. We want to enter these points in your calculator. So you want to enter this data in your calculator. So you're going to go to Stat and Edit. So hit number 1, Edit. And to save a little time, you can see I've entered these points in the table. So put X in L1, put your Y's in L2, and then you can do second mode, that quits, but it saves this data in your table. Now it says use technology to find an exponential model. Okay, I have my numbers in there. So I go back to Stat. This time I'm going to calculate. So again, your numbers have to be in the table before this will work. So you have to edit first. Now we're going to calculate. Scroll down through here and find exponential model. And here it is, EXP regression. So that's going to write us an equation. And it's pulling from list 1 and list 2. And this gives us our exponential model. And you can see y equals a times b raised to the x power. That's our exponential equation. And it gives us an a value, a b value. And it gives us this r squared is 0.98 basically, and r is 0.98. Remember, the closer r is to 1, the better your model is. So this is a very strong correlation. So that means it's giving us a very good model. All right, so this is our equation. We are going to write that down here so we don't forget it. Okay, y equals A was 163.729 times 1.084. And the 4 followed by 8, so we could round that to a 5. And that would be to the x power. And then again, because r was 0.98, that shows a very strong correlation as well. So this would be our exponential model, and this shows that that is a very good correlation. Now, while we're looking at this example, I'm going to show you how you can graph this and see both the scattered plot and the equation. So if I go to y equals, and I go to vars, scroll down to 5 where it says statistics, hit enter, over to equation. That's going to copy the equation that my calculator just wrote in here without rounding it. Okay, so that's going to allow us to not only graph the scatter plot, these points here, but also the equation on top of it. Now, we're not seeing anything. Well, because 0, our y's start at 150. So we're going to have to change our window in order to see this. So let's say our x's need to go up to above 28. Let's change our negative to like -2. You have to have a negative number in here, but it doesn't have to be -10. So let's go up to 30. A scale of 1 is probably fine. Let's do our y values. Let's again start at -2. And let's go up to about, let's say 1600. All right, this time we don't want a scale of 1 because that's going to like really kind of munch everything in there. Let's say a scale of 250. All right, and now we hit graph. This is going to show us our equation. Now, obviously, I don't have the scatter plot turned on because we're not seeing the points, but we can still do that. So if we go second y, if I notice my points are not there, it says scatter plot turned off. Let's turn that on. I can turn that on. And now when I graph it, the points from the table are in there, and it shows us our equation. So the calculator is very handy if you know how to use it. And you can see that this does represent this data. So this is a good model. And again, 0.98 tells you that it's a good model, but visually seeing that, I kind of like to see that. All right, so it says, then use the model and the models to estimate the number of visitors in 2020. So from the table, you can see this is years after 1990. So 2020, how many years is that after 1990? So that would be 30 years. So that means we're going to substitute 30 in for our x value. All right, so y equals 163.729 times 1.085. And again, 2020 would be 30 years after 1990. So just substitute that in. Then we can use our calculator to get a good estimate. So hit second quit. We can just type this in, 163.729 times 1.085 raised to the 30th power. And that's going to give us about 1892. So 1892. And again, that's an estimate based on the model we wrote using our TI-84 calculator. So again, it says estimate the number of visitors. So we can estimate the number of visitors in 2020 to be about 1,892. Example 5, finding a logarithmic model. All right, it's going to be very similar to the exponential model that we found. So just like with example 4, we have to enter the table into our calculator and then ask it to write us a logarithmic model. So it's not too difficult. We've done it with linear, quadratic, cubic. Now we've done it with exponential, and now we're going to do it with logarithmic models as well. So again, the calculator can write all types of equations if you know how to enter the data. All right, so the first thing I want to do is, let's read the problem here. The atmospheric pressure decreases with increased altitude. At sea level, the average air pressure is 1 atmosphere. The table shows the air pressure P at several altitudes H. Use technology to find a logarithmic model of the form H equals A plus B ln, that's your natural log, remember, P that represents the data. Estimate the altitude when the air pressure is 0.75 atmosphere. All right, so pull up your calculator. First thing you need to do is second plus 4. That means it's going to clear your list from the previous table. So second plus number 4, clear all list. All right, so that clears the list from before. Go to Stat and Edit, and we're going to enter this data. Okay, I'm going to pause the video and enter the data. Hopefully you will do the same. All right, hopefully you entered the data in your calculator. Once you do that, you do second quit. That's going to save my data. Now I'm going to go to Stat, and this time I'm going to calculate a logarithmic model. So if I scroll down through here, remember ln is my natural log. So let's hit enter. It's pulling from my list 1 and 2. That's what we want. So enter through that. And it's going to give me this model. So you can see h equals a plus b, ln p. That's given us the same equation, just different variables here for x and y. So y equals a plus b, natural log of x. They're just using p for x and h for y in this case. All right, so let's write down this model. All right, so a is 0.86 and y is negative 0.645. All right, so if I want to write that down, I'm going to have h equals 0.86. That was my a value again. And then my b was negative 6.45. Again, if you want to look at that. Make sure I've got that right. Looks okay. And that's going to be ln and then p. All right, now it says estimate the altitude when the air pressure is 0.75. All right, so we're going to have h equals 0.86 minus 6.45 ln, and in place of p, we're going to put 0.75. All right, so if we pull up our calculator, we should be able to calculate this. So let's do 0.86 minus 6.45 ln, and then 0.75. And that's going to give us about 2.7. So h equals about 2.7. So what does that mean? This says h is in kilometers. So we know that the air pressure, when the air pressure is 0.75 atmosphere, that means the altitude is about 2.7 kilometers. 2.7 kilometers. All right, that is all for example 5. If you have any questions, please let me know.